Hello guys, the Empinated here. We are going to continue with our procedural module-based room generator. The goal of this video is to make a grid for their walls so we can modify the height of each room we generate. Also, we must add the grid corresponding to the ceiling to obtain a closed room. Let's get started. Okay guys, so let's start with the tutorial. First of all, let's open the blueprint we were working with the last time. And first of all, I wanted to make a few calculations because the last tutorial I miscalculated the some distances, and with some diagrams I made, I hope they could be useful to explain this a little bit better, and they will be appearing somewhere in the screen. So with pretty basic math, you know. So let's start. I made these corrections because yeah, we want to take the full advantage of the space of each tile. So this way they will they won't be overlapping. So this is the best solution I have come up with. So okay, first of all, let's split this struct of our relative location. Okay, so here after we did these recalculations, we just want to make the wall spawner another grid, an additional grid, because we want to make different levels of 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 tiles for to obtain different heights, of course. So let's create another local variable called relative location z. This will be a float. Let's initialize it in zeros. Okay, and then a for loop that will be running the loop body. You just connect the rest of the code to the loop body, and it will be running from 0 a to the value of a new variable called grid z that will serve as as our as our height. Let's call grid z, and let's subtract 1. Also, let's make it instance editable, and let's expose it on spawn to alter directly in viewport. After the cell spawner, let's alter the value of relative location in z with a sum of the actual relative location plus the offset. This way we are making sure that the cells won't be overlapping, and they will be spawning one after the other one. So, and also I was forgetting, let's put the relative location in each of the cases for our vector position. Let's run it, and yeah, as you can see, it is indeed working. It isn't overlapping in any side, but we have an error because, as you can see in the screen, the first the first walls are spawning, like are getting attached to the pivot of the wall. So we just need to find a way to push upwards the first um the first walls in order to yeah, but take the full advantage of this space, right? So in the screen there will be appearing some of the diagrams I made to explain this a little bit better, as I said before. And yeah, this is some pretty basic math, not rocket science, guys. And yeah, let's apply those. We obtained after a few operations that our relative location will be better with 80, not 0. We are obviously taking a little bit more of advantage of the full space of each tile, but we're just getting um, we're just missing a little part, which is still overlapping. So in order to achieve that, we just need to do some adjustments of, as as I said, it's some pretty basic math. So it's a subtraction between the offset and another variable called, let's call it tile thickness. Oops. Will be a float, just in case. In my case, the tile thickness is 40. So let's put it. This divided by 2. And finally adding again the tile thickness. In order to get the maximum space of tiles from both the grid and the walls, and again prevent overlapping. So let's test this up. F8 to detach from the player and navigate through the viewport to the level. And yeah, as you can see, our final diagram is correct, because they are not overlapping in any sense. And yeah, we're just getting we are just taking, sorry, the full advantage of our each of our tiles. So this will be it for the wall spawner. Let's go to the cell spawner to make a little modification with this array. We're just going to place a branch before the add array, because we are getting an input working as a condition, a boolean called I don't know, is base actor. If it is a base actor, it will be saving each tile in the base grid actors. And finally, let's modify a little bit our grid generator in order to create the ceiling, because we have usually the rooms have a ceiling, right? So let's see. First of all, let's make some space here and add a for loop between the first for loop and the variable, the setting of the variable offset. And this for loop will only run through uh, two indexes, 0 and 1. 0 for the base tiles, and the 1 for the ceiling tiles. Okay, so this is why we made our input here in the cell spawner. Okay, because let's say if this index is equal to 0, is because it is still generating the base tiles. Okay, and if it's not 0, is because it is generating only the the ceiling tiles. Okay, obviously you can alter or modify the code as you want. Okay, and let's create a variable, a local variable for C component. Let's call it yeah, C component, because we want to play um, with the height in which the ceiling tiles will be spawning. Okay, so in order to spawn the ceiling tiles in the right place, we need to multiply the grid Z with the offset, or with another name, the side length, in order to get the ceiling tiles after the last row of walls, and also preventing the overlap, the overlapping that is a little bit annoying. So let's add also the tile thickness in order to take the full advantage of the space of each tile, as we previously said. Let's add the value after both x and y loops have finished working. So this way we are prioritizing the spawning of the base grid, and then we can spawn the ceiling grid. Okay, so that will be it. You can pause, obviously, if you are getting lost or you're not understanding, and also you can feel free of making a comment or send me an email. I don't know. I will try to respond. So let's keep it 3 by 3 by 3, just to test. Yeah, it's working. It's working, and obviously it isn't overlapping because of the few calculations we made. They are correct now, so there there will be no problem with this. As I mentioned the last video, in the thanks to the nature, the modular nature of these rooms, you can spawn as many as you want, and yeah, make your own cities or etc. Let's spawn a 4, a 2 by 3 by 10 to create like a tower. No matter that, I know it looks weird. We will be making more adjustments through the series to make them look properly. So thanks for watching the tutorial. Stay tuned for part 3. Okay, thank you guys. See you.